Hello everyone, welcome again. Let's introduce you C# conversions. In C#, there are two ways to change the data type of an integral value from one type to another type: casting and converting. We have two types of casting: implicit cast and explicit cast. And in this lecture, we wanna focus on them. Alright, first let's talk about implicit cast. An implicit cast is an automatic conversion and can occur if the target type is larger than the source type, which means that we can assign a value of a smaller type to a variable of a larger type. For example, here, the byte value is implicitly cast to an int and assigned to the variable myInt. This implicit cast is allowed because int is a larger data type than byte. Okay, let's show you another example. In this case, since the line type can represent a larger range of values than an int, so we're allowed to do this casting. Alright, now let's talk about some implicit casting rules in signed and unsigned numbers. Implicit casting in signed numbers can occur from smaller types to larger types. For example, the S byte can be implicitly cast to short, int, and long types, and short type to int and long types, and finally, int type can only implicitly cast to long type. And these rules are the same for unsigned numbers as well. For example, the byte type can be implicitly cast to ushort, uint, and ulong types, and ushort type to uint and ulong types, and finally, uint type can only implicitly cast to ulong type. Okay, but what if we wanna implicitly cast signed and unsigned numbers to each other? Generally, we cannot do an implicit cast from signed numbers to unsigned numbers because unsigned numbers cannot represent negative values. But it's possible to do an implicit cast from unsigned numbers to signed numbers, except for ulong type. For example, the byte type can be implicitly cast to short, int, and long types, and ushort type to int and long types, and finally, uint type can only implicitly cast to long type. Okay, now how does implicit casting occur in native-sized integers? In these types, an int can only implicitly cast to long, and on the other hand, an uint can only implicitly cast to ulong type. Alright. Let's dive into VS Code and shows you some implicit casting examples. As we said, implicit casting in signed and unsigned numbers can occur from smaller types to larger types. For example, let's say sbyte mySbyte equals 4. And in the next line, int myInt equals mySbyte and long mylong equals mySbyte. Okay, let's display them in the terminal. As you can see, in this example, the implicit casting occurs automatically because sbyte is smaller than int and long types. And this is the same for unsigned numbers as well. For example, let's say ushort myushort equals 4 and uint myuint equals myushort, and finally ulong myulong equals myushort. Now let's display them in the terminal. Alright, now let's do an implicit cast from a signed number to unsigned numbers. As you can see, our codes are going in red because, as we told you, unsigned numbers cannot represent negative values. Okay, now let's do an implicit cast from an unsigned number to signed numbers. As you can see, this casting is possible because int and long can represent a larger range of values than a U-short. But we cannot do an implicit cast from a U-short to short type as we did here, because a short cannot represent a larger range of values than a U-short. Now, let's ask you a question. Suppose we have an int variable. Can you guess what type this variable can be converted to? Okay, let's see. As you can see, we only can do implicit casting from int to long because the long can represent a larger range of values than an int. And on the other hand, because uint and ulong cannot represent negative values, so our code in these two lines is highlighted in red. Alright. So far, we said an implicit cast is an automatic conversion from a value of a smaller type to a variable of a larger type. But what if we wanna convert a value of a larger type to a variable of a smaller type? This is when the explicit casting comes in. So let's talk about that. This type of casting must be done manually by a cast operator. And as you can see in this syntax, to perform a cast operation, the target type is explicitly written in parentheses before the value to be converted. For example, here we have an int variable and we wanna cast it to a byte. In this case, the int value is explicitly cast to a byte and assigned to the variable myByte. And since the value of myInt is inside the range of a byte, the result of the explicit cast is correct. But note that this type of casting may result in data loss if the value being cast is outside the range of the target type. For example, here, the value of myLong is outside the range of a byte. So, the value is truncated to fit within the range of a byte. Okay, but how data loss happens in this example? Or what is mean of the value truncation? Let's illustrate you. In this example, we wanna assign 720 to a variable of byte type. And we know that byte can hold 256 numbers, which means it can represent range of values from -128 to 127. And obviously, 720 is outside of this range, so the value must be truncated to fit within this range. And as you can see, the truncations happen multiple times. In the first and second times, the values are outside the range of byte. But at the last time, the value becomes -48 and this value is inside the range of byte. This is the meaning of value truncation. And on the other hand, since our number has changed from 720 to -48, so obviously we have data loss. Alright, now let's dive into VS Code and show you some examples. Okay, let's say int myInt equals 28, and in the next line we go for byte myByte equals parentheses inside them byte, and finally myInt. Now let's display it in the terminal. As you can see, since the value of myInt is inside the range of a byte, so the result of the explicit cast is correct. Now let's show you another example. Let's display it in the terminal. Okay, in this case, our data is lost because the value of myLong is outside the range of a byte. so the value is truncated to fit within the range of S byte. Alright, in general, in explicit casting, we can convert all integral numbers to each other. But it's important to note that if we do not pay attention to the range of data type values, this type of casting can result in data loss. So we should use it carefully. Okay, done. See you soon.